Geometry A, Objective 5, looking at conditional and logical statements. So, conditionals and logical statements. A conditional is a statement that has if-then in it. Okay? Conditional. So, if this happens, then that happens, right? It's kind of like um, your parents may say something like, you can go to the football game tonight if you finish the dishes first, right? So it's a conditional. Um, in geometry and in logic, we'll take that same statement and we'll always put it in if-then form. If you finish the dishes, then you can go to the football game. Okay? What's right after the if, we call the hypothesis. So if you finish the dishes, right after the ifs is you finish the dishes. That's our hypothesis statement. So whatever after the if is our hypothesis. Then you can go to the football game. The conclusion, which is what we named what's right after the then statement, or the then part of it, is you can go to the football game. So that's the if and the then. They're the hypothesis and conclusion for a conditional statement. If this, then that. If this, then that. So that's the type of logical statement we're talking about. So we're going to practice some of these. And basically just getting them into the right form. Okay. So if I give you the statement, oh, I forgot one thing. If and only if. If and only if. The statement I just gave you, if you do the dishes, then you can go to the football game. Those aren't always exclusive. They don't have to both happen all the time. Okay? They don't have to both happen all the time. I mean, you could go, well, Mom, can I clean my room instead? Or, Mom, the dishwasher's broken. I can't do that. And she might still let you go. Right? There are some things that happen to happen all the time together. Right? So, if and only if. Okay? We use that. Equilateral triangles are a triangle is an equilateral triangle if and only if it has three congruent sides. Basically, I can say it backwards and it still makes sense. A triangle has three congruent sides if and only if it is an equilateral. Okay, so that's the biconditional that uses, instead of if then, it uses if and only if. By the way, definitions in geometry need to be written as if and only if statements. Right? We need statements that we can say that, if this part is true, then that part has to be true because that's the definition of it. So if and only if statements are very powerful in defining what we're talking about in algebra. Okay, and that's a decent example. If a triangle has three congruent sides, then is equilateral. If the triangle is equilateral, then it has three congruent sides. Those both make sense, so I can write it as a triangle is equilateral if and only if it has three congruent sides. Has that biconditional quality to it. Is very, very powerful. So let's start with those. Oh, there's the bell. Let's start with if today is Friday, then tomorrow's Saturday. So if today is Friday, then tomorrow is Saturday. Well, what's the hypothesis of that? Well, we said before the hypothesis is whatever's right after the if. So today is Friday is the hypothesis. The conclusion, whatever's right after the then, is what we put here. So this is all we're really looking at, is just breaking these up. Conclusion, tomorrow is Saturday. Hypothesis, today is Friday. Oh, one other thing about the thing if, or about the if and only if. If and only if. Mathematicians tend to turn things into shorthand, right? Use a symbol to shorten things up, right? I mean, even in our math, we use variables instead of writing out an unknown number, right? We don't say 5 times an unknown number equals 25. Or if we do say that, we don't write it. We go 5 times an unknown number equals 25, right? So, like I said, math people, we tend to try to make things short and pretty. So we've made an abbreviation for this statement, if and only if, and this is it. IFF, if with 2 F's. So that's a statement we use, if and only if. One other thing about converse, inverse, and contrapositive. We're going to go back up to the statement. If today is Friday, then tomorrow is Saturday. The converse, we take the hypothesis and conclusion and switch them. So the converse would be, if tomorrow is Saturday, then today is Friday. Well, this one happens to be a biconditional, right? Because that's true. But it's not always the case, right? If I win the lottery, then I'll quit my job. If I switch that one around, if I quit my job, then I'll win the lottery. Now that doesn't make sense, because if that was the case, then I think everybody would go quit their job, because that would mean they were going to win the lottery, and that's not the case at all, right? So the converse, you switch the hypothesis and conclusion. The inverse, you leave the hypothesis and conclusion, but you change them to the opposite of what they are. Okay, so if today is Friday, then tomorrow is Saturday. If today is not Friday, then tomorrow is not Saturday. Again, with the biconditional, the one that you can flip around and it still works, that works too, right? If today is not Friday, then tomorrow is not Saturday. But on the lottery one, if I win the lottery, then I will quit my job. If I do not win the lottery, I will not quit my job. Well, the thing is, I could not win the lottery, and I probably won't because I don't play it. And I don't know. Well, this job I like, but my last job I didn't like, and I quit, and I went back to school, and I became a teacher. So without winning the lottery, I quit my job. So that doesn't necessarily hold true, that if I do not win the lottery, I will not quit my job, right? And also, someday I will quit because I'll retire. So again, I expect not to win the lottery, and eventually I will quit my job. Contrapositive. Contrapositive, you do both of those things, right? Contrapositive, you not only switch the first part and the last part, you also make them the opposite. So if today is Friday, then tomorrow is Saturday. Switching them in both senses would be, if tomorrow is not Saturday, then today is not Friday. And that's true. If tomorrow is not Saturday, then today is not Friday. That makes sense. But let's look at the other one. If I win the lottery, then I'll quit my job. If I do not quit my job, then I did not win the lottery. Well, that one actually makes sense too, right? So that one's a conditional statement that the biconditional does not work. It's not a biconditional. but the contrapositive still holds true. Okay, so if I tell you guys if I win the lottery, then I'll quit my job, you guys are hanging out 10 years from now. And for some reason you're wondering what I'm doing, and you're talking to a friend of yours, and the friend says, "Oh, I still think he's teaching over at Crampton still." Well, then you know I didn't win the lottery, right? Because if I did not quit my job, then I did not win the lottery. That contrapositive works even or all the time. If the original statement is true, the contrapositive is true. All right, so you got a lot of notes to write that I didn't write today. We'll see how it works out when I grade you. Talk to you soon.